Hey everyone, welcome back. Today we're going to look at solving linear systems by elimination. If you've completed the previous linear function videos and the linear systems intro, then today's lesson will be a lot easier for you. And so today we will solve linear systems algebraically by elimination. So let's dive right into it. Example 1. Solve the linear systems by elimination. So this is important here. If your teacher does not specify how to solve a linear system, in what way they want you to do it, you can solve it any way you want. But if they say, oh, you must solve it by elimination, then you have to follow and solve it by elimination. So here's our first system here. And so what we're going to do is we line them up in standard form, right? Ax plus by equals c, like that. And we want to see if there are any of the variables we can eliminate by combining the functions together. And so in this case here, an addition does that. If we go negative y plus y, we get 0y. And so if we add the two equations together, we get 3x equals 3. Our y here disappears. And so now we have 3x equals 3, and so x equals 1. So x equals 1 is the first part of the solving this system. So now we need our y value. So if we have x equals 1, we can plug it into the first equation or the second one, and we will get our y value. So if we plug it into equation 1, we notice that it's 1 minus y equals negative 1. And then this brings us to y equals 2. And so the solution to this system is 1, 2. And we're going to check it. Remember, a solution to the system means when you plug it into each equation, it's true for all of the equations. So if we plug it into equation 1, we get 1 minus 2 equals negative 1, which is what we're supposed to get. So equation 1, no problem. Let's look at equation 2. 2 times 1 plus 2 equals 4, and it's supposed to equal 4. If it is a solution. So that's excellent. So 1, 2 is a solution to this system, and we solved it by elimination. So I'm going to do lots of practice for you guys to really catch it. Lots of examples. So B, here's our next system here. We notice that if we add them, the y will disappear. And so this is what we want. We are eliminating our y. So we're going to decide to add the two equations together. And so we get 2x equals negative 4, right? Negative 5 plus 1 gives negative 4. And so we have that. 2x equals negative 4. Therefore, x equals negative 2. So we're going to plug that into equation number 2 because that's easier. So we have negative 2 plus y equals 1. And so y equals 3. So the solution to this system is negative 2, 3. And once again, I'm going to check it. Plug in negative 2, plug in 3, and we do get negative 5. Excellent. Plug in negative 2, plug in 3, and we do get 1. Excellent. And so this solution is a solution to the system. And when you're doing a test or homework or anything, I highly recommend that you check your answers. Okay, number C. X minus y equals 3, 2x plus 3y equals 6. So we notice that we can't just add or subtract. We have to change something, right? They don't add up to 0. So what we can do is say, okay, well, this first line, this first equation, right, L1, this is the first line, we're going to go times 3 to the entire line. And it'll still be the exact same function, right? If we're going times 3 on both sides, it's still true. And so here we have 3x minus 3y equals 9, like that, right? So our first line times 3 to everything gives us that. And the reason why we go times 3 is because now we have negative 3 and plus 3, like that. So we can eliminate the y if we add. This is a little plus here. So we're doing this line plus this line. And so we get 5x equals 15. So 5x equals 15. And so our solution is x equals 3. And so now we're going to plug in x equals 3 into equation 1. and so we get 3 minus y equals 3, and so we get y equals 0. So the solution to this system is 3, 0. And I leave it for you from now on to check all those answers if you'd like. Okay, D. Here we have 2x minus y equals 1, 2x minus y equals negative 2. We notice that if we do the first equation minus the second one, so we have 2x minus 2x gives 0, negative x minus negative y gives 0, 1 minus negative 2 gives 3, and so if we combine the equations together, we get 0 equals 3, which is false. In other words, there is no solution to this system. Okay, E. X plus 2y equals 2, 2x plus 4y equals 4. You notice that we go times 2 everywhere, right? So they're the same thing. And so that's what we're going to do here. We're going to go, because we're solving it by elimination, but even just by inspection, you can see, oh, they're the same line. But let's keep going by elimination. So we're going to go 2 times line 1. So we get 2x plus 4y equals 4, like that. And now we're going to do first line minus the second line, like that. So 2x minus 2x is 0, 4y minus 4y is 0, 4 minus 4 is 0. And so we get 0 equals 0, which is true. And so that means there are infinite number of solutions. They are the same line. So this is what it looks like when you're solving it by elimination. Okay, F. Here's our system. We notice that minus y plus y can be eliminated, so we're going to add the lines together like that. So we get 5x equals 5, meaning we get x equals 1. We're now going to plug that into equation 2, and so we get 2x plus y equals 5, which gives y equals 3. So the solution to this system is 1, 3. Okay, so we've had a lot of examples where the y's eliminate, but sometimes the x eliminate. So we see here is our system, and we notice 2x and 2x. Well, that's beautiful. We just go 2x minus 2x, and it's gone. So we got negative 3y minus y gives negative 4y. 4 minus negative 4 gives 8, like that. And so this gives us y equals negative 2. We're going to plug that into equation number 2. So 2x plus negative 2 equals negative 4. So we get x equals negative 1. And so the solution to this system is negative 1, negative 2. Okay, H. Sometimes we're not given it in standard form, and so we have to rewrite it ourselves. And so if we do that, we get x plus 2y equals 1, and then here we get x minus y equals negative 5. So we notice that these x's can be eliminated. So we're going to go first line minus the second line, like that. So x minus x is 0, 2 minus negative 1, 3, 1 minus negative 5, 6, like that. So which gives y equals 2. We're going to plug this into equation number 2, like that. And so we get 2 equals x plus 5, so x equals negative 3. So the solution to this system is negative 3, 2. Okay, example number I. So this is tricky. 2 and 3, and then 3 and 4. So what we're going to do is go times 3 to the first line for the x's here to be brought up to 6. And then we're going to go times 2 to the line 2 so that this 3 is brought up to 6, like that. All right, so I'm going times 3 everywhere, we get that. Times 2 everywhere, we get that. And now we're going to eliminate the x. So we're going to go first line minus second line. So 6 minus 6, 0. 9 minus 8, 1. 3 minus 2, 1. So we get y equals 1. We're going to take this y equals 1 and plug it into our first equation. So 2x plus 3 times 1 equals 1. Do the algebra and we get x equals negative 1. And so the solution to this system is negative 1, 1. Okay, so I did lots of examples. Time for you to do lots of practice. So solve the linear systems by elimination. So go ahead and pause the video and answer that. Okay, we're back. So start with A. We notice that the y's can be eliminated, so we add that. We get 2x equals 4. Therefore, x equals 2. Plug in x equals 2 into equation 2, and we get y equals 1. So the solution is 2, 1. B. We notice that the x's can be eliminated, and so we're going to subtract. So we're going to go first line minus the second line like that. So 2 minus 2 is 0. 1 minus 3 is negative 2. 10 minus 6 is 4. And so this gives y equals negative 2. Plug that into equation number 1, and we get x equals 6. And so the solution is 6, negative 2. Okay, C. We're going to go times 2 to line 1 so that the x's coincide. And so we're going to eliminate, actually it's going to be 2 minus 2 is 0, 6 minus 6 is 0, 8 minus 8 is 0. 0 equals 0 is true. Therefore, there are an infinite amount of solutions to the system, and they are the same line. D. 3x plus 4y equals 7. 3x plus 4y equals 10. So we're going to go first equation minus the second one. And so we get 0 equals negative 3. Which is false, and so there's no solution to this system. E, we're given 2y equals 7x minus 14, 2y equals negative 3x plus 6. We're going to rewrite this in standard form as such, and then we notice that the y's can be eliminated. So we're going to go first line plus second line, gives us 10x equals 20, therefore x equals 2. We're going to plug 2 into equation 1, and so we get y equals 0. And so the solution to the system is 2, 0. F. First equation, second equation. We're going to go times 2 to line 1 so that the x's can be eliminated. We're going to go first line plus the second line to get 0x. 14y equals 28, y equals 2. Plug in y equals 2 into the first equation, and we get x equals negative 3 over 2. So our solution is negative 3 over 2, 2. G, here's our system here. We are going to add them because the y's are going to be eliminated. So we get 4x equals 8, meaning x equals 2. We're going to plug this x equals 2 into equation 1, and we get y equals negative 5 over 2. And so that is the solution to the system, 2, negative 5 over 2. H, 5x plus y equals 2, 5x plus y equals 4. We're going to subtract the two equations, and we get 0 equals negative 2, which is false, meaning there is no solution to this system. And that's it. It's that easy. I'll see you guys in the next video.